Okay, up to protocol technology we have discussed in yesterday class, right? That means burst-based transactions, and then what is burst-based transaction? What is transaction? A transfer or beat. Okay, one beat. How many data we are transferring? See here, beat 0. 32 bits are transferred. That means 32 means 4 bytes are transferring. Each time 4 bytes data we are transferring. And then burst length is equals to ax length plus 1, and then burst size 2 power ax size they will provide you, and then total transfers we will calculate it as burst length into burst size. Okay, so burst length is ax length plus 1 and burst size is a 2 power ax size. Okay, 2 power ax size is means number of beats per number of bytes per beat. Okay, this is burst size. This burst size will tells you that one beat how many bytes you need to transfer. Okay, so that's what ax size we are giving 7 and length is 7 and size is 3. Then 2 power 3 is 8. That means 8 bytes per beat. One beat you are transferring 8 bytes. Then burst length is 8. Okay, so 8 beats you are transferring. Total 8 beats and then 8 bytes you need to transfer per one beat. So total 64 beats. Okay, 64 bytes of data you are transferring. That is what we are explained up to this yesterday class. And then we know already 5 independent channels we are having in AXI protocol. That is write address channel. Okay, so what is that write address channel? AW address, and then that means write address channel is represented with AW, write data channel is W, write response channel is B, and read address channel is AR, and read data channel is R. Okay, read there is no response because see this is the direction read data channel. Okay, so in this direction the read data plus as well as response are also going on the same direction. That's why yeah, so that's why AXI protocol does not have read response channel. So in the read channel only the response is transferring. There is no need of extra read response channel for AXI protocol. Okay, it supports full duplex. Full duplex means simultaneous transactions will be taking place. That means master is sending write data and then slave is sending read data, because write and read happen simultaneously. There is no, because each and every channel have their own read response channel. There is own handshaking signals, valid and ready signal. Okay, each and every channel have their handshake signals. That's why handshake when it is happening, your valid signal should be high and then ready signal should be high. Both are at high on the same clock cycle. Then only transfer will be happen. Okay, so that is the handshake process. If before ready signal is high, before the valid signal, ready signal is high means here also sampling is not happening, and then after valid signal and then your ready signal will be high means here also data sampling is not happening. Whenever the valid and ready signal both are high, then only transfer will be happen. Okay, so that's what master sends that valid signal high and slave sends that ready signal should be high. Both the signals are sending at the same clock edge, then only we will transfer the data. Okay, so after when you are desetting their when you are desetting that ready signal means after last transfer, then you can deset your ready signal. And then what is the protocol violation here means whenever my ready signal is high and the next cycle we need to maintain throughout the transaction valid signal should be high. Okay, valid never goes low throughout transaction. Okay, whenever whenever my ready signal is high, after one cycle your valid signal is going low means you're losing your handshake mechanism, then that is protocol violation. Okay. So and then simultaneous read-write operations we are having, right? So each channel having same different type of signals. The address channel, AW address and AR address for writing and reading. Writing, AW address is there. For reading, AR address is there. And control signals. What is the control signals? Size, length, and then AW size and AW length. Similarly, AR size and AR length, and AW burst and AR burst, protect signal, and all these are controlling signals, because based on the length and size we are mentioning that how many beats are transferring or how many bytes are transferring per beat. Okay, so that will tells about these control signals. And data signals, what is the data signals we are having? W data and R data. W data for write data channel and R data for read data channel. And other signal W strobe, W last, R last, and ID. These are all other signals. While defining which bytes are valid data you are transferring, this write strobe will tells you. Okay, and then last signal, that means last transfer happens, your transaction is closed. That means W last will be high, means your transaction, your communication is completed. And response signals, D response and R response. Response signals are there, not the right response is there, right response channel is there, and right response signal is also there. But right response, read response signal is there, but read response channel is not there. Okay, that is the difference here. See, I will tell you. So simultaneous read and write operations. We are AX is the full duplex. Full duplex means I am also communicating with you. You are also communicating with me at a time. Okay, so that is the full duplex transfer, like mobile phone. Our mobile phone, we are talking each other. Okay, so we are also transferring. I am also transferring the data, and you are also talking with me at the same time. So write and read channels are independent work on simultaneously, because we have different latencies, and then so because we need to reduce the latency. Main aim is to why we go for that simultaneous access, means without delaying the bus. Okay, your bus is not in idle state. So effective usage of bus, that is the purpose we go for simultaneous operations. Okay, these are the key features. We already know that. Okay, five independent channels. Each channel have valid and ready signal. Okay, and then address channel is also there. Address and control channels we are having. For address and control channels, what is the data we are transferring? That we controls here. And read transfers is having a read channel as well as read information from we are getting from slave. Okay, always we are getting the data from the slave, that is read transfer will be happen. Always we are sending the data from master to slave. Okay, that is right information is happening, and right response will be after completion of right transaction. We need to give the right response. Once I'm we are having three phases, right? Address phase, data phase, and response phase. In the address phase, master will keeping the address, and then data phase, master is writing the data from writing data to the slave, or reading the data from the slave. And then response phase, slave will respond to master. So you are sending the correct data or valid data. So based on that, see, valid handshaking rules. Valid signal should be high. Entire, so the source device having data control signals, right? So valid and ready is the controlling signals, handshaking signals. In that, valid signal should be maintained high throughout transaction. Okay, data or control information from the source remains stable until the destination device, a destination drives the ready high. When you need to maintain high of the valid signal means, so whenever the destination, that means slave will give ready to receive the data, that at that time ready signal will be sending. Up to that we need to maintain valid signal should be high. Okay, and then ready, the destination drives the ready signal high. when it is ready to accept the control information or data information. Control information means burst length, size, and all these things. And then data information means address and write data, all these things. Okay. So when you are getting transfer happens, both the value signal high and ready is high. So that is only we are happening the transfer. Before that is also not happening, and after that also not happening. Okay. So why we are having five independent channels and each channel having valid and ready handshake signals. So because of efficient enable efficiency as well as parallel operation and full duplex communication we need to provide. Full duplex I told you, right? So parallel communication will be happening. So these are the five channels. So I told you that five channels purposes. Okay. So a right address channel. What is the purpose we are having? Right address channel. We are keeping the address to the slaves. Okay. That is the main function here. See, it carries the address or control information when writing transmission happens. Okay. Write transfer happens. We are keeping the address and data here, and then it is going from master to slave. Okay. And write data channel, that is also master to slave is happening. Okay. So it is transferring the data from master to slave. Okay. What is the use of this signal? Transfers the right data to the slave. Okay. Whatever the slave we have, it will transfer the data. And then response, right response, it gives the response. Okay. It gives either okay response or error. Okay. So error means you are received that invalid data. Yes, sir. And then AR address, write read address channel. Read address channel is also control and information is there. Okay, so address and control information is there. It is also transferring from slave to master. Okay, sorry, master to slave, because we are getting the data from slave. Then master initiate the address. Based on that address, we are getting the data. Okay. So carries the address or control information for read transaction. Okay, read transaction is happening means it will carry that AR address channel is carrying the address of the information. Okay, which address location I want to read the data. Then master initiate that address. And then read data channel, it is from slave to master. Okay. So slave to master, the data reads will be happening from slave. Okay. Whenever we are getting the data, so that is from slave, then it is getting the data from slave to master. Okay. So these are the handshake signals. And then all signals, what are the signals we have? I told you right address channel. In that right address channel, valid and ready is definitely we are having. And then it is a 32-bit address. So AXI3, it is 32-bit address. Okay. And AXI4, it is a 64. Okay. 64-bit address bit. And then AW size is a 3 bit. Okay, so size is 3 bit, we are taking 2 down to 0. And then length is 7 down to 0. In AXI4, that is 7 down to 0. Okay, this is in AXI4. And AXI3, okay, so 3 down to 0. Your length is 4 bit. Okay, up to 16 bits we can transfer. Okay, 16 bits of data we can transfer. That means AXI3 is a length is 4 bit, then 2 power 4, then total 16 bits we can transfer. And then in this AXI4, the length is 8 bit, 7 down to 0. Okay, AX length is 7 down to 0, that means 2 power 8, 256 bits we can transfer. Okay, that difference you need to tell that to the interviewer. So what is the difference you observed in AXI3? So AXI3, the length is less, and then AXI4, the length of the channel is wider. That means it is possible to transfer more data. in AXI4. And then length, size, burst, and then ID are the signals. See all these signals. So valid, ready, address, size, and length, burst type. What is the burst type we are having? 2 bits.
How to calculate that length AXI3